Welcome to our subject, Industrial Motor Control. This time, I will introduce to you one type of magnetic starter, and this is the full voltage magnetic starter. In the last video, I told you that there are two types of magnetic starter: the full voltage magnetic starter and the reduced voltage magnetic starter. Where will you use this full voltage magnetic starter? Where will you apply? Where will you connect? Where will you use? So you will use it, no, for those motor that having small horsepower. It might not go beyond 5 horsepower, or maybe the most is 10 horsepower. Then beyond that, you will be using another type of controller. There is a reason behind it. So today, I will be giving you the full voltage magnetic starter. Now, what is the full voltage? What is a full voltage magnetic starter? This is a type of starter that when you press the button, automatically the motor will receive its power voltage or the line voltage. If the motor is rated 220, then when you press the button, immediately the motor will receive a 220 volts. So that is what we call full voltage. Now, then why is it that there's also a need to have a reduced voltage? Again, I mentioned that previously, that if you have so much horsepower connected in the circuit, then when you switch on, let us say you have 50 horsepower. Now, a 50 horsepower cannot be connected in a full voltage, okay? In a full voltage magnetic starter. But you need to use a reduced voltage magnetic starter because you have to, what? You have to prevent the high starting current that might damage your motor. That might be damaged electrically or maybe mechanically. In order to prevent this, then you will use the type of reduced voltage magnetic starter. But this time, I will be emphasizing to you the full voltage magnetic starter. So, shall we say, the motor is not go beyond 10 horsepower. No? So, according to the book, if the motor will be more than 5 horsepower, you can already use the reduced voltage magnetic starter. But based on our experience, even if you have the 5 horsepower, then you will connect that directly to a full voltage. Fine. 7.5 or 10 horsepower, fine. Okay? So that is good. But if that will go beyond 10 horsepower, maybe as experience, so I will encourage or advise to use already the reduced voltage magnetic starter. Okay. In a full voltage magnetic starter, there's only one that is very important. No? This is what we call the magnetic across the line starter. So when we see magnetic across the line starter, for instance, this is your three-phase line. No? This is your three-phase line. And then you have your motor here. The motor is connected there. Okay? Like that. So if you have your circuit breaker here, you have your circuit breaker, and then you want also to control this motor. Of course, when you press or rather switch on the circuit breaker, the motor will immediately receive maybe a 220 volts. If the source is 220 and the motor is rated 220, then that is what we call full voltage. Okay, so that is the full voltage magnetic starter. Now, in this case, we will start the magnetic across the line, or this is commonly called direct online magnetic starter. Okay, again, magnetic across the line or direct online starter. Now, there are two circuits I told you. We have the power circuit and we have the control circuit. Now, how about the power circuit? So we have here, again, the power circuit. This is now the power circuit. We have the circuit breaker, we have the magnetic contactor. Of course, in the magnetic contactor, where the overload relay is connected, then inside the overload relay, you have the heater. Now, the heater is very important there. Okay? I'm going to explain that when we open, or I already explained that, no, when we study the overload relay. Okay? The purpose. And then how it is constructed inside, and then how it operates. How this heater work. So I already explained that. Now, so then you have your motor. So this is your power circuit. Now this time, I'm going to give you the control circuit here. First, I explained this before when we studied the overload relay. This is your what we call the overload contact. In the overload contact, you have 95, you have 96, and then of course there is a normally open there. Then this is your 98. If you are a motor control tender, if you are the one installing the magnetic starter, see to it that you are aware of the terminal mark. Okay? And then we learn that we have your push button here. Push button stop. And we have here the push button start. Okay? So we have here, I will say this is stop. And this is start. Button. Off or on button, same. So you will notice that the push button stop and start are connected in series. As a sort of reviewing, these are momentary push button. So when you press the stop button, it will open. But when you release your finger, it will go back to normal position. The same for start button. And then we have your magnetic coil or holding coil. So this is connected to line 2 and line 1. Meaning to say, you will connect here and here. You connect that parallel. Because control circuit here is a single phase. The control circuit is single phase. So you have here, by the way, now if I'm going to press the button here, I on the circuit breaker, then I want to run the motor now. When I press the button here, of course, this will energize. So once the magnetic starter is energized, this will close. Okay? Then the current will flow going to the motor. The motor will receive 220 volts, considering that this is a full voltage. Then the motor is running. But if I'm going to release my finger here, what will happen? The motor stops. I said, this is momentary push button. When you press the button, this will touch here, this will contact here, energize, the main contacts close, motor is running. But when you release your finger, it will open. Why? Because this is momentary push button. There's a spring tension there. So in order to let the current continue flowing to the holding coil, so that the magnetic contactor is always closed and then the motor will run, you need to put a holding circuit. And then this holding circuit is called maintaining contact. Okay? This is maintaining contact. So, what is that maintaining contact? This is the one responsible to let the current continue flowing to your holding coil or supply to your holding coil when the push button is already, when you remove your finger from the push button. So how? You will use now the auxiliary contact from your contactor. What is that? This one. You have three main contacts here. You have the line 1, line 2, line 3, and then the other one, this is your auxiliary contact, normally open. Okay? Now, we discussed that when we studied the magnetic contactor. You will connect your auxiliary contact, normally open, parallel to your push button. Then, of course, this is your 13 and 14. So, if you look at your magnetic starter or other magnetic contactor, no? You have here, you have your 13 here, and you have your 14 here. Meaning, this is your auxiliary contact normally open. I told you when we studied the magnetic contactor, there is no magnetic contactor that do not have normally open auxiliary contact. So this is the minimum contacts found in a contactor. You have the 3 main contacts and 1 normally open contact. Remember, that would not be considered a magnetic contactor without an auxiliary contact normally open. Okay? That is it. So, again, this is called maintaining contact. Maintaining contact. That one. That is your maintaining contact, or in electronics parlance, this is called latching contact or a holding circuit. So when you press the button here, this will energize. So once this will energize, of course, this auxiliary contact is coming from your magnetic contactor. Okay, coming from your magnetic contactor. So when I press this one, this will energize and this will close. Then, upon releasing my finger, the current will continue flowing because you have already the maintaining contact. Okay? So, the motor now is running normally. Now, if you want to stop or off the motor, simply you press this button here. Now, look at that. So, when pressing this button, the flow of current will not continue flowing. Diba? It disconnects the circuit. So, this is de-energized. The magnetic contactor is energized. So what will happen also to your contact here? This will go back to normal position, normally open. And then when you release your finger, it will go back to normal position. Then the circuit now is open. Motor stops. So that is what we call our what? What do you call this diagram or conductor? This is what we call direct online. Direct online magnetic starter. That's the name. Run. So direct online magnetic starter or magnetic across the line starter. Okay? So that is our first connections of magnetic starter. I will demo this. Now, this is the actual connection. You have here the line 1 and line 2 and line 3. And then you have already the what we call the wires for control circuit that is already connected in this push button. You have the magnetic conductor and you have the overload relay. So this is already complete. Then what you will do, you just simply connect your motor here, line 1, line 2, terminal 1, terminal 2, terminal 3 to your motor. And this portion here, line 1, line 2, line 3 to your circuit breaker. And circuit breaker is connected to power source. Then that completes the power circuit. Okay? So that is our direct online magnetic starter. So again, for the demonstration on how to connect it, you don't need to worry because I will demonstrate it. We will really run the motor using the direct online magnetic starter. Now, why we have this? Why is it that our motor will be controlled by direct online? This is not only to start and stop the button, the motor, but this will also protect your motor from any overload because of the overload relay. Now remember, relay and magnetic contactor is entirely different. But there is a definition, one book I read it, that a magnetic contactor is still considered as an electromechanical relay. Then I also read another book, it will be control relay. That is also electromechanical relay. But the functions are different. Now, the purpose of the magnetic contactor is to connect and disconnect the power. Okay? That is the purpose of the magnetic contactor. So this is usually used in a three-phase source. If you have a magnetic contactor, this is usually used in three-phase source. While the control relay or a relay is only good for single phase. So I made it clear. Magnetic contactor usually used in three-phase source, while a relay usually used in a single phase source. So that is the difference between a contactor and a relay. Okay? So for our next video, we will study the two station. Okay? Two station. Meaning, you can control that particular motor in two stations. You can off here, you can on here, or you can on here, you can off here. You can on, you can off, you can on, you can off. Meaning, motors, if we will base on the lamps connected in two locations. So this time, a motor is connected in two locations, or controlled in two locations. Controlled in two locations. So we will be having that. So there are many diagrams that I'm going to present to you. Okay? I'm going to present to you. So this is also very, very important. So we will do it slowly. So after this pandemic, no? If we are already allowed to go to our laboratory shop, please, will you connect the actual insulation or the actual connection. We have plenty of magnetic contactors. We have plenty of overlay as well as push buttons. So you will really learn on how to do this. But I just simply give you this time the diagram. I hope you understand. Thank you and good day.